All right, so check this out. You wanted some help with gas laws, and let me give you the gist of it. There's really, for this chapter, there's one equation, and it's PV equals nRT, perv nert. And the idea is that this number can change, okay? This number can change. The P can change, the V can change, the N can change, the T can change, but the R is called the universal gas constant. It doesn't change, right? So if you have PV equals nRT for this situation, for situation 1, and PV equals nRT for the situation 2, the R is going to be the same in situation 1 and situation 2. The P, the V, the N, the T, those can all change, except the R stays the same. Does that make sense?
Yeah.
Because it's called the universal gas constant. And I think, I don't know it off the top of my head. Let me just look it up real quick. But R is something like 0.82. I don't know. Let me look it up real quick. All right. Gas laws, pressure conversion. Okay, here we go.
0.08.
0.08206. All right, so R is equal to 0.08206 as measured in liters, atmospheres, Kelvin, moles. Liters, ATM, K, mole. Now make sure that the units on this is actually important. You could measure it in, instead of atmospheres, you can measure it in pascals, and then your R would be a different number, and you'd have to look it up. Okay? Or, so whenever you're dealing with pressure, if they give it to you in a pressure that's different than what you're used to, then convert it to, or then atmospheres, then you should convert it to atmospheres. If they give you the volume that's different from liters, you can then convert it to liters in order to use this. Here's a really important one. If they give you a temperature that's not in Kelvin, so they give it to you in Fahrenheit or Celsius or some other weird one, you need to convert that to Kelvin, and that's super important. And then molarity or moles, they probably won't give you anything different, except maybe what we'll do is we'll give you like the grams, and then you got to figure out how many moles. Well, that would be molar mass conversion from chapter 2. Or maybe we might give you liters of a solution or something like that. And then you have to convert that to moles. That's chapter 4 as far as molarity goes. Right?
Yeah.
All right. So the first problem says, read it off to me, and you got to read it loud.
A particular balloon is designed by its manufacturer to be inflated to a volume of no more than 2.5 liters.
Okay.
If the balloon is filled with 2.0 liters helium at sea level, is released.
So 2.0 liters of helium at sea level. So at sea level means 1 ATM.
Is released and rises to an altitude at which the atmospheric pressure is only 500 mmHg.
500 mmHg. Okay.
Will the balloon burst?
Okay.
Assume temperature is constant.
So we assume the temperature is constant. There's also something else we have to assume. We have to assume that the N is constant. But I mean, if you think about it, if you have 5 moles of helium in here, and then when it goes up to the top, how many moles of helium are you going to have in there? How many particles are you going to have in there? Is it going to be different from here to here?
Yeah.
No. N isn't going to change in this situation or in this situation. This thing's going to get bigger, but as far as the number of moles you have in there,
Oh, okay.
I didn't say I added a gas, right?
Yeah.
Or the gas leaked out. Maybe that would be a stipulation that you would have to assume. The gas didn't leak out, or somehow another gas didn't seep in there. So, okay, so here's what we got. PV equals nRT. This is kind of what's known. I told you that the equation is PV equals nRT. That's pretty much the only thing you need. One way to look at it is PV over NT is equal to R. I just solved for R there, right? So in this situation, let's call this situation initial. So I'm going to put a little I on the bottom here. I think on some other places I put a 0 or a 1 or something like that. That's just like the first situation. Got it? Is equal to R1 or R initial. And then I got P final, V final over N final, T final is equal to R final. Does that make sense? But there's no such thing as R initial and R final because R initial is equal to R final. Does that make sense to you? R is the universal gas constant. This is 0.08206. This is 0.08206. In the initial case and the final case, it's the universal gas constant. It's going to be the same regardless of which time you're talking about. Does that make sense?
Yeah.
So this R is equal to that R, then this thing is equal to that thing. Right? So this would be like, this is the combined Avogadro and Boyle's and Charles' law, all wrapped up into one. But what they're telling us is they said, assume that the temperature didn't change.
Yeah.
And also assume that the number of moles didn't change. Physically, that means assume that gas didn't leak in or leak out or whatever. So if N1 initial is equal to N final, I can just cancel those out. Does that make sense to you? And if T initial is equal to T final, I can cancel those out. Look, this is, I think this was called Boyle's law. P1 V1 equals P2 V2. I don't expect you to memorize Boyle's law. I expect you to memorize PV equals nRT and understand that Boyle's law just comes from that. Does that make sense? All right. Then really it's just a matter of figuring out we want to figure out what the volume in the end is.
Yeah.
Because if the volume in the end is bigger than 2.5, then the balloon popped. Does that make sense?
Yeah.
So if we want to figure out what V2 is, you just divide both sides by P2. And this cancels out with that. And then you have 1 ATM times 2.0 liters divided by 500 mmHg. And the problem here is you have to convert mmHg into ATMs.
Okay. So
let's just do that on the side real quick. 500 mmHg. There's 760 mmHg per ATM. So it's 500 divided by 760. So whatever that is. So you just plug in 500 over 760 and you get your answer. This is actually pretty straightforward and easy problems. Yeah. There's just a lot of them.
Yeah.
That's why it's 53 points.
0.659.
Yeah, whatever that answer is. All right, so are we good? Do you have any questions with this thing?
Yeah, because they're all the same, right?